A very common law that we have in science today is called the inverse square law. And it really just talks about the intensity of radiation coming off of a point source or a spherically distributed source. For example, the gravitational field coming off of a spherically distributed mass, or the light from a candle or from an incandescent bulb, or the radiation from a radioactive point source. All of these things obey what's called the inverse square law, which means that the intensity of the radiation field goes down by the inverse square of the distance from the source. And that really just comes down to the radiation is being uniformly distributed over a spherical surface at a specific distance. So let me show you in mathematics. If you have a radiation source coming from the point right there, then that radiation, if it's uniformly distributed, is going to be averaged over a sphere of radius capital R. Now, that area of that large sphere is given by 4 pi r squared. If you go to some other surface of a sphere, say this inner one, the red, that might have a radius, say, of 1 unit, 1 meter, 1 light year, 1 distance, then the ratio of the intensity of the field, this is radiation coming out from that point source uniformly, the ratio of the intensity at the little r to the big R is just the ratio of the surfaces, because the radiation is being uniformly distributed over that spherical source, because it's coming out in all directions with equal probability. So when you look at the math, the ratio is really quite simple. The 4 pi's cancel. When you look at these ratios right here, remember the little r is 1, and so the intensity at this larger distance is 1 over r squared. So the intensity comes off as 1 over r squared as you go out some distance. That's the inverse square law.